From reading this problem, some people might be able to guess that this is a combination of Newton's second law and kinematic equations. So what we're going to do is we're going to write out all our knowns and inferences and talk about perhaps what we need to find. So what we do know is that the weight of the truck, so I'll say force due to gravity on the truck, is 19,000 newtons. We know that the initial velocity is 25 meters per second. Driver panics when an elk runs onto the road. So the driver wants to brake and stop. So basically that means that we can infer that the final velocity is 0. In the problem, it states that the coefficient of friction, and since the truck skids, we'll say its kinetic coefficient of friction, it's going to be 0.68, no units. And what they're asking is, what is the final position of the truck? This is assuming that the initial position is 0. We can assume that the initial time is 0. And, from this, we can even infer what the mass of the truck is, assuming that it's on the surface of the Earth. So we can say that the mass of the truck is this divided by 9.8 meters per second squared. So that'll be 1938.77551 kilograms. And yeah, so we're looking for where the final position of the truck is. You can also say, since we know that x naught is 0, we can also say that delta x is what we need to find. So either one of these two is okay. Let's go ahead and first invoke the direct equation that involves trying to find delta x. So given what we have here, and just so you know, if you have force, you more likely have acceleration as well. So given here, the best equation is a kinematic equation that looks like this. Okay, I'm going to box what I need to know. We have V final, we have V initial, but we don't directly have acceleration. So in comes the side quest right away, and we're going to try to find the acceleration. Based on Newton's second law, the acceleration of the truck is equal to the sum of forces acting on the truck divided by the truck's mass. We know that when a truck is skidding, we're going to assume no air resistance. So we're not going to assuming that there's a hill. So we all make all these little assumptions, and we say that the sum of all forces must just be the force of friction. So force of friction kinetic divided by m. We're going to further break this down, and the force of friction kinetic is just mu times normal force divided by m. Now, again, this was mentioned a few other times, but just in case we forgot, for a problem where the truck is not going up or down on a horizontal road, or I guess any object's not going up or down in a horizontal plane, the force of normals is going to equal to the force of gravity. So normal force is equal to gravity. This is due to the fact that if we were to take the y component of sum of all forces for a truck that's not moving up or down, we'll see that normal force pointing up is equal to the gravitational force pointing down. So that being the case, we can go ahead and say that acceleration is the is mu k. And now normal force is just the force of gravity, so it's just going to be the mass of the truck times g, and we divide it by m, which is also the mass of the truck. That being said, let's go ahead and take out the m's, and we have mu k times g. And that's going to be acceleration. Now, this is the acceleration magnitude. Everything, basically all the equations we're giving you, especially if we were to break them down into one dimension, this being in the x-axis of the problem, it's going to be scalar. So it's going to give you a positive acceleration, but we already know that if the truck is traveling to the right and applies their brakes, the acceleration is going to go to the left. So the travel is going to go to the right, but the acceleration is going to go to the left. So we can automatically say that solving for this, the acceleration is 6.664 meters per second squared. but we have to artificially put a negative sign there because we know it's going to go backwards. So from this side quest, let's go ahead and plug it into the original kinematic equation, which we're going to bring down here. So VF squared is equal to V naught squared plus 2A delta X. And now we know all of these three parameters. VF is going to be 0. V naught is going to be 25 meters per second. And now acceleration is going to be negative 6.664 meters per second squared. Delta X by itself is going to be V final squared minus V initial squared divided by 2A. And plugging in all these values, we get delta X to equal 31.88775551 meters. Now, we're going to get into two significant figures since our problem gives us two significant figures as the least number of significant figures. So we finally conclude that the distance that the truck will skid once applying the brakes is 32 meters.